Alright, from the given problem, we came up with this equation, which is the H2 is the limiting reactant, and thus we make the coefficient of H2 is 1. Therefore, we came up with this equation, and we did not overall with A, B, and C correspondingly. Alright, for the initial part, since the reaction is taking place in gas phase, so we are using molar flow rate, which is FA0. And take note that the value here is 0 due to the fact that the ammonia is product, and here the value for the change is negative because it is reactant, and the value here is positive due to because it is a product. And last but not least, the remaining is simply the summation of initial and change.
Move to the second question where it asks us to find the initial concentration, delta, and epsilon. So the first one, the initial concentration, is actually just simply by rearranging this, which is the ideal gas law, PV equals to nRT. So we arrange in terms of concentration, but bear in mind that this is the total concentration, so we will multiply with YA0, which is the gas fraction, which is already given. Now we have all the data, we substitute it and we get the final answer, 0.2 mole per dm cubic. Now for delta, it is just simply the stoichiometry of the product minus the reactant. So we substitute the stoichiometry and we get negative 2/3. How about the epsilon? It is just simply the multiplication of YA0 and delta, so we multiply and we get the final answer, negative 1/3. Now it's time for the harder part, which is the conversion and finding the final concentration. But it isn't really that hard, it's just simply using this formula, which is just a rearrangement of the ideal gas law, which we know C equals to F over V. And we know F equals to plus F naught X because this is from the stoichiometry table, and it's positive because it is for the product. And for V, yeah, it is the rearrangement from the ideal gas law as I mentioned, V0 plus this, and the thing is, these two, P0 over P and T over T0 will be equals to 1 because it is an isobaric and isothermal process. So from there, we just simply substitute all the values that we have and we get the final answer. But bear in mind that we have to multiply with the stoichiometric coefficient, which gets us to the final answer, 0.1 mole per dm cubic. For hydrogen, it's simply the same except for the fact that this is a negative because it is a reactant. So substitute the values and you get the final answer.